assignment will be about the Dragon, the version alpha of this thing. This is one of the best assignments in the whole course. The easiest, the fastest solution, the shortest solution was 24 lines. The average solution is around 100 lines of code, which with tests, and it includes both doc test and test. So there is a assignment, the whole content and functional requirements that we need to fulfill. There is also some of the non-functional requirements. It's all about the simulating the software development process and pursuing the fulfillment of the acceptance criteria, but in the same time not to over-engineer the whole thing. Okay, so now we will proceed to the creating the Dragon. Okay, first, it is very important to start from test. We will be doing the whole assignment starting from the something which is called test-driven development. But before we start, we can think about designing our Dragon. So we know from the functional requirements that we need to create a file and then to create a class representing a Dragon. The class has name, position, texture, file name, and hit points. But the most important of this is the game, so the use case. And if you start writing your code from the use case, from the API, to be honest, because use case describe the API. So we have something like that. Create Dragon at this position and name it Wawelski. Okay, so we can start from this, and then we can pursue with our doc test just by fulfilling each of those statements. And for this particular reason, we have something which is called ADR. ADR, so architectural design records, are the documentation about the design considerations that you took during the development of your source code. So first, this is the ADR template. This is how the ADR looks like. So you have the name. In our case, this is a moon landing, just as a template, the example. The status of this ADR, which is accepted. We have the decision date when it was taken, okay? So it was taken on 25th of May, 61, and it was publicly announced, publicly released, something like this, on this day. Who were deciding? This is, of course, the fictional people who are the parts of our training course. So context and problem statement. So these are the main cause why we have to do this exactly decision. So before this decade is out, we need to land on man on the moon and then return him safely to the earth. Why we are doing this? Decision drivers. So in order to demonstrate the technological superiority, win the space race, and so on and so forth, invest 200 million in plants and laboratory facilities, create a new jobs and contracts for over $1 billion, and so on. This is in 60s, so it's a huge pile of money. This is the reason why we are doing this. What we also considered, what were the alternatives? So the long duration spaceflight to orbital station, Mars landing, or just doing nothing. So imagine this as a document. For example, we want to create the front end for our application. And the decision is that we will go, for example, with React or React Native or with Angular or whatever else technology. So this is why we need this to solve. Because we need a front end and we want to separate backend from front end development and so on. Because front end can change pretty frequently and the backend will be more stable. So what were our decision drivers? So we need a flexible technology which is supported by the big company, which won't be abandoned in the next couple of weeks, and so on and so forth, which has very easy testing and integrated testing framework. It has very good support from the IDE. It has very good tooling and huge support from the community, and so on. These are our decision drivers. What others options we considered? So we consider also, for example, Angular or Next.js or React or React Native or whatever else. These are the technologies that we also considered as alternatives. What we finally decided, decision outcome. So we decided that we will go with React because the React is a brainchild of Facebook, and it's very well supported by the community. It is very good integrated with the testing environments. It has very good support from the tooling. It has very easy CI/CD process, pipeline, and so on and so forth. This is the justification why you choose this particular technology. Pros and cons of the options. Why not Angular? Because, and there's a list of whys. Why not this one? This is because this. And some references. Very simple, very short document. But if you do this kind of document for each decision, major decision that you take in your project, then you will create a documentation for your project in the end. And this is really important because most of the software systems, they lack documentation, because it's very hard to write a code and then try to figure it out why I did this in the first place. But if you create just a bullet points, just look at this, just a bullet points with the justification on some certain decisions, and then you have plenty of those files in your repository, like 50 of those files. When you have a new person coming to your team and he wants to start programming in your project, give him these ADRs, and he will for sure he will come up, well, why we are doing this in React, why not in Angular? And then you point him to this document and say, please read this document, and you will know why we chose this decision. Because sometimes the decision is, for example, context dependent. It's not that we are choosing the best framework, is that we have to choose, for example, some other framework because we have 5 Angular programmers, and besides the fact that, for example, React might be the better solution, but we don't have anyone who knows the React, and we have 5 Angular programmers. And this is something which can go to this document, okay? And this is very important because if you do something like that, then you will be able to justify your decision. And this is amazing and powerful tool for all of your audits. So let's have an ADR for initiating our Dragon with some basic stuff. Here is the just only for CI/CD that it will skip this file. So Dragon ADR init name. So we have the problem to solve. Create a dragon and name it Wawelski. Okay? So when we create a dragon, we can create a dragon this way. Or we can, so using positional arguments, or we can use keyword arguments. Positional arguments are easy to use, but less verbose than keyword arguments. Keyword arguments are easy to use, more verbose, more explicit than positional arguments, but to be honest, too verbose for such a simple example. So our decision here is that we will go with the positional arguments. It is easy and verbose enough for now. It may be changed in the future, but for now this is a good solution. So we take this line and we paste this line here. Look, we are starting to document our code without even writing even single line of code. Then we have second part of this statement. Create dragon at this particular position. So init position ADR. Our statement is create dragon at this particular position. So we can do something like this. The problem here is that this is very easy to use, but not explicit enough. So the problem here is that we are not sure what it will be, those numbers, what we have those numbers for. So it requires the knowledge of API to answer what are those numbers, what is the meaning behind them. It does not suggest that the X and the Y are some kind of parameters, for example, to texture. Because if you do something like that, Wawelski 00, it does not give you any other sense. This one, it also does not give you the sense that you will set the position to the default value. In my opinion, this is a bad design record. This is a bad decision. And especially if you do something like that, if you do something, maybe without this bad here, and if you do something like this, you put the name of a texture here, those numbers may change their meaning. It might now reflect that those are parameters to the texture, width and height of a texture, or percentage like zoom or shrinking or resize, volume and quality, or something like this. So now those numbers has completely different meaning. Because positional arguments, they have a meaning which is created by position of those. When this thing, Dragon, Wawelski, it's quite self-explanatory, but not this. In this case, we have point 1 and 2, which is, in my opinion, it's more or less okay. So this point 1 and 2, it's okay. Point X and Y, it explicitly says what is the meaning behind X and what is the meaning behind this. But okay, but the name is overkill. It's explicit too much. It's an overkill. I mean, this is not a good name for a class. I don't think so. Okay? This is maybe okay. I do understand that probably if I'm creating a class point, then those two will be some kind of coordinates, but I'm not quite sure. If we have a Cartesian axis point, then, or point on Cartesian axis plane or wherever on a Cartesian plane, then we for sure know that this is X and Y, because this thing means that all points needs to have X and Y. If we have GPS points, this is for sure a bad decision, because it does not refer to X and Y, it refers to longitude and latitude, and it's definitely not X and Y. So you don't have, so look at this, you have different points. All of them are some kind of points, but they have different meaning behind those points, different naming conventions and so on, and some of them are okay and some of them are not okay because you do not provide the context, and it's very hard to guess from the context. So this is our option 1. In my opinion, the verdict for the option 1, not good. We can write something like that, verdict, not good. Option 2, we do something like this. So the Dragon, Wawelski, X and Y, easy to use, good. Short argument names, very good. Good. Verbose, verbose in this example. So if I take something like that, very good, not a problem at all. You can assign none to each of those values to set to the default point coordinates. It's very easy to extend. So if I add, for example, z-axis in order to make a game in 3-dimensional, I can create an init function within the Dragon class with the z parameter set to, for example, z equals 0. I don't have to provide this. It is very easy to convert 2D game into 3-dimensional one. It's very easy, it's very extensible. The previous one, if I add another, it does not necessarily has to be a position. It could be some kind of other parameters. Here, it's very easy to do so. So the first one, for sure, not good. The second one, better. Verdict, better. But still not good. Why? Imagine this some kind of situation. We have X and Y. This is okay. But is this X and Y referring to the coordinates of this? Maybe some kind of properties of this position. It does not explicitly say. Here you may get the idea that it's all about the point and the coordinates and so on. But here, when they introduce the texture, it might change meaning. It's not, I would say, it's not exactly what we can come up with. So Cartesian point, Cartesian x point was something like this. So with the first one, point, x and y, in my opinion, this is very good. It's very good, to be honest. X and y, okay, but the name is overkill. It means there's too much information. There's a duplication x and y here and x and y here. This is a very good one. The first one is a very good one. Cartesian axis point, okay. This is very good. It provides the information, but in this case, bad, because GPS uses longitude and latitude for this particular reason, so this is not a good thing. So imagine also something like that. There is the algorithm which is called K nearest neighbors. It's a machine learning algorithm. I think I have a picture of this. KNN, architecture and VC. No, I don't, unfortunately. So this is the machine learning algorithm. Give me a second. I was trying to search for some kind of nice example. K nearest neighbors algorithm. And yeah, K nearest neighbors. If we have a data set, give me a second. I will check one of the, yeah, something like that. So let's take the browser, and here's this solution. So we have something like this. We have X and Y. So these are two categories of some kind of data. I don't know, maybe people. And we have people. This is height and this is weight. And we are trying to categorize people who has, for example, problems with weight. So they are obese, they are overweight. Okay? And these are the category for people who has high weight but the high height, big number of height, so they're high, and they're the people who are having a larger weight. So you have two categories, and there is a new data point in here. Okay, is this person overweight? And there is an algorithm which is named K nearest neighbors. So you select, for example, if you run this algorithm with the parameter K equals 3, it means that you have to find 3 nearest neighbors to this data set, to this data point. So there's a 1, There is second, this is the closest one. This is the second one, and I think maybe this one is a bit closer than the red one. So out of 3 nearest neighbors, 2 are green, so the new data point will be green. Okay, it's very easy. So what does this k parameter name stands from? What does it mean in this class? What is the meaning of this parameter? Okay, the meaning of this parameter is the number of nearest neighbors, because the class is called k nearest neighbors. So this is the number of nearest neighbors. It's all in the class name. But what does it mean w equals 1, 2, and 3? The problem here is that the w do not provide any meaning for us. We have a problem because we don't know what does k was self-explanatory, because in this context the k is very too easy to understand, but w is not that self-explanatory. So option 3, we can name this pos x and pos y, or a pos underscore x or pos y. But here we have a bit of the problems like that. So it could be okay, Wawelski pos x, pos underscore x, whatever. But this is, let's check with this example, k nearest neighbors. So please remember that we are talking about the game, but we are also talking about the programming in general. The Dragon game is only a narrative for us to explain the good concept behind the design and object-oriented programming. WGT, you may come up with the idea that this is weight. So for example, in this algorithm, you might have a weight with this. So for example, this data point has more weight to it. It has more meaning. So despite the fact that this point here is, for example, only 1 red within the scope of 3 points, but it has more weight in general, then you multiply the length, for example, and this new data point could be categorized as red one because those 2 green ones are further away. Okay? So it could means weight. But does it? Maybe there are some other meaning to this. It's not that clear, to be honest. It's not very clear. We can do better. So in my opinion, the verdict is still better, but not good. The fourth one. So we have a dragon, position X, position Y, position X, position Y. This is the convention from Java, JavaScript, and so on. It's not a Python convention. Python convention is this. The good, simple, easy to use. You can assign none by default to set default point. And it's very easy and extensible. It's very easy to convert. So it has all the pros from the previous one, but it does not have the con. It is verbose, and it is verbose enough. It's like with this k nearest neighbor example. K equals 3. The 1 letter character is not always bad. In this case, 1 letter character, variable name is very good because the meaning is here. But the other one was problematic. But now we don't have any problems at all. It's self-explanatory. We don't have any problems with understanding why is this for and what is the meaning behind this. So there is another problem with those two. In pandas, there's a function, it's called, on a data frame, it's called plot. In order to get a plot, a chart from the data, kind line subplots equals true, color equals gray, and share equals true. What does this share parameters means? So the problem here is that the share parameters might be a bit of confusing, and you might not get to the first impression that this is share y-axis. If these parameters were named something like that, or say axis, or share y-axis, it will be self-explanatory. Or share axis y, something like that, because now it has, or maybe something like this, share axis now y, true. Now it's very easy to understand, it's very easy to comprehend, and without having any doubts. Okay, axis or share axis y, or something like this, all of those will be okay, because there is no second meaning to this. There are self-explanatory. It's a bit more to write, but maintenance, code readability, quality is very good. So in my opinion, better, good enough, good, very good, good, could be used. The fifth one, position and a tuple or a list, doesn't matter. So the good thing here is that the data is stored together as a coordinate. It's simple to use, simple, easy to use. You can assign none to the default to set the default position. So to set you can assign none to set default position. Yes. You always have to pass x and y coordinates. Together. But the problem here, it's also a bad thing that you have to always pass both of the coordinates together. You cannot set only one coordinate. You cannot set only one axis to none, for example, to default value in x coordinate or whatever. You always has to know that the first one is the x and the second one is y. It's not self-explanatory. It's not self-explanatory. The order here is important, and you cannot confuse it. You cannot change it. You have to do the unpacking, and it's not extensible. The position will always be 2D. It's not possible to use 2D position. So the problem here is that if we want to later on in our code, if we want to change from 2-dimensional points into 3-dimensional points, we have to find all tuples or all list, 2-element list, using this kind of regular expression. And then maybe this list indicates the point. It's not clear. So in my opinion, the verdict here is bad. Bad by design. Bad, just bad. Bad by design. So I'm not going to use it. But not going to be used. The next one, maybe pos xy, xy pos xy or position xy. So the problem here is that it's a bit more self-explanatory here, but the problem persists. It always needs to be tied together. It always needs to be, you have to unpack, you cannot pass only one, and you are stuck with 2D. It's not extensible. So the verdict here is bad, not going to be used. The next one, maybe a dictionary. So dictionary will be easier to refactor this than a tuple. You have to use this pattern. It's very uncommon to have to find this in your code in cases which it does not reflect the point, because it's kind of uncommon for data to be named X and Y and they are stored together and they mean something different than a point. So it will be easier for sure, but this is the same problem. It's not extensible to 2D. So the verdict here is bad. We are not going to use it. The next one, maybe we can create a named tuple. So position will be a named tuple with this kind of coordinates, and then we can also deal without having to specify even the name of a parameter. The name of a parameter is a bit overkill because you have position equals position, so you can even deal with something like that. This looks very nice, both of them, position 50, 120, and this is even better. And to be honest, I really like this solution and this solution. Those two are very good. So this is very lightweight. In the end, this is a tuple. They have meaning, so you have to pass both X and Y. They are relatively easy to extend to 3D. You just add here and your compiler will throw an error whenever it has position with only 2 coordinates. So at least someone is telling you where you have an error. So right now it's far easier, okay? It's better than before. But we are not going to use it. Nine, name tuple. Oh, we can create a name tuple, but this time not from collections, but from typing. In fact, this was created by the same person. He created this many years ago, and then a couple of years ago he created name tuple. And this has all of the things from the previous one without the problems of the previous one, and changing to the default is that simple. I can write here with the Z coordinate, and it's now 3D point. And whenever I did not pass this value, it will default to 0. So it's very easy to extend to 3D. It's very extensible. In fact, this is a very good solution. Very good solution. And the verdict here is very good solution. It could be used. It could be used. In our case. Next one, type dict. The problem with the type dict is it could be used, but it's a bit more. It's a bit more too much. To be honest, the name tuple are far lighter. They are still tuples. They have exactly the same features as type dict, but they are tuples. They are lighter. And there's another thing. In Python 3.9 and 10, they lack support for default values. That's default values for type dict, and ability to say which one is required and which is not. It will come in 3.11. So my verdict here is a good solution, but there are some limitations. So there are some better solutions. Okay. The API of the type deck will change in Python 3.11, which is 1 month from now. We don't want to use some kind of solution which will change in the future. Then we can include required and not required, and it will support default values. Then we can re-evaluate them. Okay, so, but there are some limitations. We can re-evaluate this in future. Re-evaluate in future. Okay, 11, data classes. Maybe we can create a data class out of it. Every point will be a data class. The data will be stored together as a coordinate system. Simple to use, verbose. You can assign none by default to you can assign none to set default position. It's very easy to extend. Just add z and it will be 3D. And keyword argument is not required. Class name is verbose enough, but you can also use keyword argument. So in fact, this is very good, but there is one downside. When you have a data class, it can have some additional things. So for example, I can pt y equals I don't know, maybe 2. This will pass. But even if you set, for example, something not existing, it will also pass. Because of the dynamic nature of the classes, you can set the attributes and not even to not existing ones, and it will create this attribute within the point. We don't need this feature. It's an overkill. So the verdict, good solution, but there are some limitations. It's not that limitations. It could be better, but there was a better solution before. There are some limitations. How about data classes with a frozen set to true and slots set to true? Oh, this is a very good solution. So now you won't be possible, you will not be possible to do something like that. Okay, you won't be possible to will throw an error. So changing the default will throw an error because it's a frozen. So you cannot change the values, but you cannot also create a new ones because this is a slot. Slotted classes are simpler. Slotted classes are faster than just their normal classes, but this is a bit more complicated than mutable date classes. So the trend here is quite good, but in my opinion, there's too complex. Too complex for now. Maybe in future. Re-evaluate in future. Okay? It's a bit too complex. How about setting a point to a class? It has the same problem as before. So you can change to whatever and it will pass. Okay? It's not frozen. So the problem here is the same as with the data classes. So it is a good solution, but there are some limitations. All of them will pass. You can create a point with some additional things. Slots will remove these limitations, but the problem here is the same as with slotted data classes, that we don't need this now. We can reevaluate this in future when we will have some problem, when we will have some information. So slotted class will throw an error whenever you want to set a new argument, but it will allow to change current one. So something like this. This will pass and this will throw an error. So this decision here, too complex for now, reevaluate in future. Decision, the outcome of the whole document. So the outcome of the whole document is that we will go with this. This is good, explicit, verbose, and extensible. Alternative, reconsider in future, re-evaluate in future. We can go with the name tuple or the data class with frozen and slots. That would be explicit, verbose, extensible, but for now it's a bit too complicated. Too complex for now. Too complicated. For now. We don't need this. Extensibility and features for now. So in the end, we came up that this is a good decision. This is the way where we should go. Very good. You developed the first line of your code. So we had a conversation for almost half an hour or so, and we came up with the one solution. But now, check this out. We have very well documented, resonate why we came to this solution, what are the alternatives, and why we are not using those for our program. When we will have the audit or external auditors will come to our project and they said, oh, why you didn't do it this way? Then you can give them a document which explicitly says why you did those kind of decisions in the first place. And this is amazing. And another thing which is amazing, you are creating an API here, and the decisions about the API are very crucial. We still haven't created any lines of code, but this is very simple. You create a class dragon now, pass, and you create a class dragon test now with test. So we can which inherits from test case, which will import from the unit test case. Here we go, test, just test init, whatever, pass, and let's see if the testing framework works. So first, let's use the doc test, and the doc tests are running, and there's a problem because Dragon takes no arguments. And let's do the unit test, and the unit tests are passing because we don't have any assertions in here. So basically now our job is to fulfill the code. So first we will write a test, okay? So test init. To be honest, we should create this test when we were setting up the name. And then it will be very easy to extend to the positions. So we have something like that. Test init name. We chose that we will go positional with the name which needs to be a positional. So if I create a dragon Wawelski, then I self-assert equal, I want to make sure that the dragon name will be Wawelski. Okay, something like this. Okay, I will fulfill this in a second. But there is also another test. Test init. So maybe let's first write a code in order to incorporate this. Dragon.name. Alt enter. Add name to a class dragon. Here you go. That will be the name parameter, and we need to take a name parameter from here. That will be a string. Okay, we are now setting, we can run the test and test, yes, it's green, so it's working. And now we write another test because we established a protocol that we will not allow for people to use keyword. So we want to with self assert rises type error whenever a person will try to create a dragon but to use the name for it. Okay, and we want to make sure that it will yield a type error. In order to do so, we run the test right now. The test fails because its type error is not raised. So now we need to do this by doing this. It will pass the test. And now PyCharm does not recognize that we are here checking the errorous situation. So PyCharm thinks that we made an error, but we did this on purpose so we can tell him no QA that this is not an error, this is the expected thing. Please do not treat this as an error. We are aware of this. Okay. Then we should go with the positions, and then we write another test. Define test init position positional. So we came up with the idea that the positional will not work for this. So we don't want the situation like that. Okay? And we don't want the situation in which the first one will be this and the second one will be something like this. Okay? And we don't want the situation in which one of those is only passed and the other one is not. So currently, if we run this, then the test will fail. Of course, the positional argument follows the keyword argument. So we have a, of course, because this is already tested, so we cannot do this. So we don't want this kind of situation for position y, neither this situation nor this. So now we need to run all the whole test suite. Okay, the whole test suite currently is running because it takes a type error because we don't take this argument. But as soon as we will start to taking the position x, which is the integer, and position y, which is the integer, and we want them to be passed as a keyword arguments. Okay, so we do something like this, and now we should pass them as a keyword arguments. Our test will fail because required position only arguments. So init, yes. Now check this out. Init name positional. The problem is in here. So when we were introducing some new features, we broke the features of previous API, and test has this amazing possibility that if you write test, they will check also the regression. So if your new feature is not breaking the previous ones, in our case, yes. So now we can take into the consideration the decision whether we want here to create a dragon without the specifying the position, or we does not allow for this. In our case, we can allow to set a default position, so that would be something like that, 0 or none, whatever. And check this out, the test for name found an error in the default position. Good. And now we write a test, define test init position keyword. Okay, and if we create a position keyword, so we do something like this, then we self and we of course position x, that would be 1, and position y would be 2. Then we self assert equal that the dragon position x will be 1, and then self assert equal dragon position y will be 2. Please note that we do not specify the same value here and here, because you may confuse it later. I mean, by the confuse it, it may pass a test when the position is invalid, or I made a wrong code. So here avoid value 0 in both cases, and make sure that this is distinct values, because we want to make sure that those elements were set independently. And do not check name here, because it's all about testing the position. We do not test the name, we test the name here. So we do something like that. We check if the test passes. Of course it's not passing, because it's no such attribute as a position x. So we create an attribute x position, and of course as a position x, and then we create a position y attribute as a position y in here. So we have a name, which will be the first one, then position x and y, and of course we'd like to have the type annotation in our class, because we are good programmers and we like type annotations. So let's make them in good order, something like this. So this is the first solution. Later on we will do improvements on our solution, but first we need to fulfill the requirements, okay? So this is the API and requirements driven development. So I am fulfilling the requirements, but first I am writing also a test, and there's a one test which is missing, the default value. So if I create a test position default, I do not set the values, and then both of them should be 0, 0. Unfortunately, as a default, both of them will be set to 0, 0, so they have to have the same value here. So let's check if the test passes. Yes, the test passes. Then check if the doc test passes. They pass. So we can edit the configuration and we can do something like that. This is a doc test, and this is the unit test, and we don't need those. The alpha test. I think this is the better one. So this is unit test, and we don't need this one. Of course, here you go. Run the test, and now we have doc test, unit test in here. First one, second one, perfect. Good, very good, very good. So as you can see now, we have 5 unit tests, 1 doc test, and a couple of lines of code. But all lines of code, they are 100% tested. And this is very good. If both tests passes and we are happy about the solution, then we can go to the next line. The next line is set the new position to x equals 10 and y equals 20. So we go into our ADR. I will check, I will only copy this to the position set ADR. So our goal here is to set a new position to x10 y20. The first option is to use fly, teleport, set position x and y. All of them are easy to use. They use encapsulation, so they store the values within the class. They do not manipulate the attributes on their own. They hide the abstraction, and the whole reason behind the object-oriented programming is to encapsulate values. There are four paradigms, or maybe not. There are 4 values in the object-oriented paradigm: encapsulation, abstraction, subtraction, inheritance, and encapsulation, abstraction, polymorphism. Okay, Those are 4 foundations for the object-oriented programming. And encapsulation is all about hiding the internals of our class and do not exposing the attributes outside. So this is a good practice for object-oriented programming. In Python, it's a bit different. You can manipulate the attributes just like that. In Python, it could be done, but in general, it's a bad practice. So those functions are good, easy to use. They use the encapsulation, easy to add the validation if needed. So for example, if the coordinates are not negative or something like that, it's very easy to extend to 3D. Just add another parameters to the function and it will be easy to do. The name set position X and Y ties you to the 2D point. So this one is not good. Arguments are explicit and requires the knowledge of API. The name, teleport and fly are bad. They does not indicate the context, okay? Maybe not the context, but you will use them only in a game, okay? You won't use them in any other case. The set position, it's kind of generic, and not every element in a game can teleport or fly. So for example, you cannot take the same code and apply it to a chair, because chair does not teleport or fly. The chair could be moved, the chair could be pushed or whatever, but it cannot be teleported or flied. So those are bad names. They are too specific. The arguments are implicit, requires the knowledge of API, what the values are provided, so that this is X and this is Y. But to be honest, maybe not with the last one. The last one clearly indicates what is the meaning behind this. But in my opinion, you don't have to worry about this. In this case, we are programmers. We have some certain of education and some kind of experience. If you set the position, everybody will understand that this is X and Y or something like that. You can do better. You can ask for X and Y. So in this case, good solution, but could be done better. Okay, the next one, fly and teleport, the same, are bad names, too specific, too use case specific. Okay, it's very easy to extend, and set position, which takes X and Y, good, verbose, very good solution, good solution, could be used. This is our candidate, the first candidate. So set position. Maybe just set and then position X and Y. Easy to use, arguments are explicit, encapsulation, but the problem here that this is a gateway to abuse. So with this thing, it says that you can virtually set all of the attributes, and this makes encapsulation in question. So I will say that this is a bad thing. So it's not it might not encapsulate the values. Okay, it might be a gateway to abuse and make the encapsulation in question. So good practice will be questioned here. So the verdict, bad. Not going to use. To be used. Won't use. Okay, maybe manipulate the X and Y coordinates. Yeah, you don't want this, okay, in your class. KNN W equals 1, 2, 3. So with Dragon, no. Bad by design, not going to use. maybe this. Dragon position X, dragon position Y. To be honest, this is easy to use. Arguments are explicit. You can use properties for validation if needed in future. But it does not have the encapsulation, so it violates OOP good practices. In Python, you can do this. You will be excused. People won't have any problems with this. But in general, there are better ways. Why not this set position function that we had before? So this would be okay. I would say okay, but there are better solutions. There are better solutions. Okay, so this is okay, but there are better solutions. So why not to use something like that, like a position this or position at this point? The problem with this thing here, it is, so in English it makes sense. Set dragon position at this point, and the same for this, dragon position at this point. So, but this makes only a sense in English. In Polish, this sign is małpka, which means a monkey, or in Russian is sabaka, which means a dog. So basically, dragon position dog point or dragon position małpka monkey, this thing doesn't make sense in those languages. It does only make sense in English, and you cannot expect that all of your targeted audience will be English speaking, or at least they will know the meaning of this. So in my opinion, this is not that good solution. It ties you to the 2D, especially this one, and it's not extensible, hard to refactor this to 3D verdict, but not going to use it. Not going to be used. Not going to be used. Not going to use it. Okay, the option 7. The option 7 here. So here, bad. Not going to use it. Position X and Y. So you have a dragon. There is this object position, and it has the coordinates X and Y. Easy to use and so on. It provides a namespace. It's more or less readable, extensible. It exposes the API. Okay, it requires the knowledge of API. It's nested. No, bad. Not going to use it. No, bad design. So our decision, final decision, is set position, and with the set position we will this function, because it's easy to use. Arguments are explicit. It provides an encapsulation. Provides encapsulation. Easy to add validation if needed, and it's extensible. Easy to refactor to 3D. Okay. So this is our thing that we're going to use. We copy this line. We set it here. And we've developed the next line of our code. Now we need to create a test. Test, define, test, position, set. Check this out. The first test was all about creating a dragon in different ways. So this is init test. And this test are all about position now. Position test. Okay? So it's a position, it's a different set of tests. Later on we can refactor those out into separate tests. It doesn't necessarily need to be now. But later on we will be able to do this. So position test. When we set a position, test position set. So we take a dragon, but we can already have this dragon prepared. So that would be another section, setup, for all of our tests. Define setup. And since from now on, we will create a dragon at this particular position. So we will create self dragon at this particular position. And there is something that I will like you to share with you also in a second. And now we can use this already created dragon to set something. So self dragon, set position to x equals 1 and y equals 2, but we will use different initial positions in here. And I will tell you in a second. So this is keyword, and we don't want this to be positional. So whenever there's a positional, we expect that this with self assert rises type error dragon set position, and whenever someone calls this way, it will have to yield an error. No Q8, it will yield an error, but we have to implement this feature in a second. So now set position function, I click Alt Enter, and then PyCharm will give me the ability to set this. This will be integer required. This is also integer required, and we need to fulfill the narrative, fulfill the features here. So self position x equals x, and self position y will be a y here. Okay, so we are using both of them, and we require both of them to be passed as a keyword argument. So a keyword arguments something like this. And now we run the test, our doc test passes, unit test, all the unit test passes, and we are sure that we completed the feature, another feature in our code. Okay, the most crucial part here is that we have two tests. One test is positional, and then the second one is keyword. We are expecting only this kind of arguments. So why I chose this particular position on one or two? Because in a second we will do move or a position change or whatever features, and we will move our dragon by some kind of offset to the left, to the right. If I set this here to 0, 0, which is a perfect default position, and then if I move this dragon, move to right, for example, by, I don't know, 10 pixels or 1 pixel even, then I have to decide now how do I handle and whether do I handle the negative coordinates. But this is not, that won't be a test. The next feature won't be a test of negative coordinates. That will be a feature of moving dragon to particular position, to the right, to the left, or whatever. But I don't have to make this decision yet if I start from 10. Because if I start to 10, then I expect that after this, the coordinate x will be 9, and I don't have to make a decision yet how to deal with the negatives. I can postpone this decision for further use. So if I make this 10, 20, it will be easier for me to do tests on position change without having to have the decision about how to treat the negative coordinates yet, and those will be the different tests, because handling the negatives is a different feature from moving left and right. Moving left and right is just offsetting a location to the left, to the right. It's not about handling the coordinates, handling the collisions. Handling collisions or out of boundaries, it's completely different test. This is very important for you to understand if you want to do test-driven development. The test-driven development is effective, but you have to think about your test that all of the tests will test only one feature at a time, one single isolated feature at a time, and do not test the same thing. We've already tested how to create a dragon, how to create a dragon without specifying the position, how to create a dragon with specifying the position, and how to create a dragon at the default position. So you don't have to create a dragon every time here just to create a set position, because this test, it's not about creating a dragon. This test is about setting the position of a dragon. So if those tests passes, you can be sure that the dragon could be created without an error. Then you create a default dragon, and then for all other tests, we will use all of the tests which will follow. We will use this one, this example dragon from here. And this setup method will be run in before each of those tests, and it will reset the dragon. So every test following here, it will have a new dragon for its own use. Okay? So there is also defined setup class. There is also defined tear down and tear down class. Define tear down class. So setup and tear down is for cleaning up after the test. So before each test, and by the way, test needs to have the test name in the name. So each test will start from setting up, then running a test, and then tearing down. But the whole class, the whole dragon test class, will start with setting up class, then running all the tests, and then tearing up the class. So you can prepare, or you can manipulate your class or a test from within those setup or tear down or setup class, tear down class methods. Okay, this is a really amazing feature if you think about this, because you can prepare your environment, you can prepare your default objects, and then you can just, as here, we need, of course, assertions. We don't have the assertions. So assert equal that our self dragon position x will be 1, and then self assert equal self dragon position y, it will be 2. Now we have the assertion. Now we have the assertion in here. In setup you don't do assertions, of course, but now we have all the assertions and all of the tests. We check the test, unit test, all passed, 7 tests, and doc test, they're all passing. Doc test feature is complete, and we can proceed further with another line. And I think we will make a break now, because the next part is the hardest one. I mean, it takes the longest time, position change, because there's a lot of different variants to cover, and I don't want to do this because I will not finish in 5 minutes, and I don't want to postpone the lunch for later. Okay, so now we will finish for now. I will make all of those features after the lunch break, and then we will complete our dragon. And when I complete our dragon, I will do refactorings. Okay, so I will change the set position and this to set position and the one function, and you will see plenty of different refactorings that I will do in order to come up with the final solution. But right now I am targeting to this 24 lines of code, more or less the final solution for this dragon. Okay, and to be fully covered by tests, both doc tests and unit tests. We will stop now.